Hi everyone, this is Mrs. Musoff. Today we're going to be talking about solving exponential equations. So in this chapter, since we learned about exponentials and we learned about logarithms, we're going to learn how to solve both types of equations. So today is exponential equations, and then the next video will be logarithmic equations. Alright, so what is an exponential equation? An exponential equation means that the variable, so x most of the time, but it could be any letter, right, or symbol even, the variable is in the exponent. Alright, so for example, 4 to the x equals 23, or 5 to the x equals 25 to the x plus 3. Right, both of these are examples of exponential equations because the variable is in the exponent, right, both of those, and then we've got an equation, right, there's an equal sign. Okay, when we think about an exponential equation, one of the most important things we talk about is the base. Okay, and the base is just the number that's getting the exponent, right? Or sometimes there are two bases. Right, but that's kind of what we're referring to. So just in case you ever hear us mention the word base, right, remember that's what it means. Okay, there are two methods for solving exponential equations, and usually one of the methods is a little bit easier, but it doesn't always work. So that's why it's important that we know both methods. All right, the first method for solving an exponential is to get the same base. Get the same base. All right, so I'll give you an example of that, getting the same base. So suppose I had the equation, let's say, I don't know, 4 to the x equals 16. All right, remember when we reference bases, we're talking about kind of these numbers here, right? And so if I want those bases to be the same, I'm trying to ask myself, is there any way to rewrite it so that it's the smaller base? And in this case, we can rewrite 16. If you're not sure how, then off to the side, you could break down 16. Right, 16, that's 4 times 4. And that means that I could rewrite 16 as 4 squared. So now these two values, the left side and the right side, would have the same base. And that's important because if I can get them to be the same base, well, if 4 to the something equals 4 to the second, then as long as those bases are the same, I can cross them out and solve my equation. All right, so that method's the easiest method, but unfortunately it doesn't always work. Like if you look at the example up here, right, 4 to the x equals 23. Well, 23, if I were to break down 23, I can't break it down into just 4s, right? So I can't get them to have the same base. So our second method for solving exponential equations is going to be to use a logarithm. Or specifically, we're going to rewrite it as a logarithm. So to give you an example of that, let's say I had 2 to the x equals 10. All right, first I would try method 1. I'd say, can I get them to be the same base? But I know that 10 breaks down into 2 and 5, and that means there's no way to write it as 2 to a power, right? Because the 5 would have to be there. So I can't get them to have the same base. And so that's when I would use a logarithm. Or in other words, I'm just going to rewrite it. Remember, to rewrite a logarithm, this base becomes the base of my log. So 2 is now the base of my log. And we kind of use a circle method. The next number we write down is the 10 equals, and then the last number should be my exponent. Okay, and when you rewrite it as a logarithm, now x is already solved for, so all I need to do is put this into my calculator. All right, and to put it in my calculator, I'm going to use change of base, so I would do log of 10 divided by log of 2. All right, and I would type that into my calculator, I would get a decimal, and that would be my answer. Okay, so these are our two methods. I'm going to go through a few examples of each just to make sure we really understand when and how to use them. All right, so the examples here, it says solve the equations. So number 1, 9 to the 2x equals 3 to the x plus 6. So the variables are in the exponents. That's how I know these are exponential. And so I'm going to try my method number 1 first because that's easier. And then if it doesn't work, I'll move on to method 2. So method number 1 says, can I take the bases, so in this case the 9 and the 3, can I get them to be the same base? Well, I know 9 can break down into 3 times 3, and that means it can be rewritten as 3 squared, 3 to the second, right, because there's two 3's. And since this is already a base 3, that would be perfect. They would be the same base. So what I'm going to do is I'm going to rewrite 9 as 3 squared. But I can't forget about this exponent. That 2x still needs to go there. So I'm going to put the 3 squared in parentheses and then put my exponent down, which is 2x. All right, the right side already had my base 3, so I don't have to worry about doing anything there. And now I just have to remember my exponent rules. Right here, this means to multiply exponents. So that becomes 3 to the 4x, right? 2 times 2, that's 4. And now, since I just have the same base, no more parentheses, I can cross out my bases. I have 4x equals x plus 6. And to solve this, I'm going to get the x's on the same side, so I'm going to subtract this x to the other side to keep that positive. All right, 4x minus 1x is 3x, so I end up with 3x equals 6. And if I divide by 3, I'll have my answer, and that is x equals 2. All right, in these problems, you don't have to check for extraneous. In exponential equations, we shouldn't get extraneous solutions. But anytime you're solving, you're more than welcome to double check yourself just by plugging it back in. All right, if I wanted to, I would just plug 2 in for both of these x's and double check that I end up with the same answer. All right, that's it. That's solving equations using method 1. Let's try it again in number 2. All right, so same thing. 4 to the x equals 8 to the x minus 3. So again, exponential equation. X's are in the exponent. I'm going to try method 1 first, and that is to get the same base. So I have a 4 and an 8. I usually like to start by trying to break up the bigger number, because like we saw in number 1, sometimes you only have to break up the bigger number, right, and then you're good. So I'm going to break up 8. If I break it up, I get 2 times 4. I want it to be 4s, but the fact that there's a 2 here tells me maybe I should just keep going and get it to be 2s. And if I do that, that means 8 can be rewritten as 2 to the 3rd. Now you might be saying, well, wait, this is a base 4, not a base 2, so how does that help me? Well, what can we do with a base 4? We can break 4 up into 2 times 2, or in other words, 2 squared. That means I can get both of these to have the same base, and that's a base 2. All right, so sometimes you can't get away with just breaking up one number. Sometimes you have to break up both. All right, so instead of 4, I'm going to write 2 squared, keeping that x there. And then instead of 8, I'm going to write 2 to the 3rd, and again, keeping that x minus 3 right there. And remember, these parentheses and exponent rules mean multiply. And here, that means I have to distribute it. So I'm going to end up with 2 to the 2 times x, or 2x. And over here, I'm going to end up with 2 to the 3x minus 9. And now that they're the same base, 2, I can cross those out. I get 2x equals 3x minus 9. All right, I'm going to actually subtract the 3x this time, just so that since the minus 9 would then already be on its own. Okay, but in doing that, now I'm going to have negative x equals negative 9, so I still have to divide by the negative 1 that's in front of the x. And that will lead me to my answer, x equals 9. Okay, again, you're welcome to check it back, plug it back in, right, and see if it works. It should, unless you made a mistake somewhere along the way. All right, let's try a couple more using method 2. So now if I take a look at number 3, 3 to the x equals 16. I'm going to first check method 1, see if I can break down 16, the bigger number, in order to get it in terms of 3s. Well, 16 I know can break down into 4s, 4 squared, but that doesn't really help me. And then I could break it down into 2s, 2 to the 4th. Again, that's still not going to help me. So that tells me, all right, method 1 is out. So that means I have to use method number 2. Method number 2 is to rewrite it as a log. Rewrite as log. All right, so that means I'm going to write the word log down. And then the base of my log is the base of my exponential, so that would be a 3. And it goes in a circle, right? So the next number I'm going to write down is 16 equals, and then the next number is x. And now x is solved for, right, because x is by itself. I just usually want to get the decimal here because a lot of people wouldn't know what log base 3 of 16 is off the top of their head. And we like to have at least an approximation there. So what I'm going to do is I'm going to type this into my calculator. Type into calc. And you might remember doing this previously. This is the change of base, right? Our calculator. I'll show it to you real quick. Our calculator has 2 log buttons right here, but this log is a base 10, as you can see the 10 right above it. And this log is a base E. So unless you have one of those 2 bases, you're going to have to use change of base in order to use those buttons. Here I have a base 3. All right, so then I'm not going to be able to use one of those buttons unless I rewrite it using change of base. So change of base says to do log of this inside number, the argument, divided by log of the base. Okay, and then that's what I would type into my calculator, and I'll show you how to type it in. I'm going to type the log button, and then 16, remember to close the parentheses, divided by, and then log of the 3. And technically, right, here's my answer, 2.52. Technically, you could type the same thing in with the other log button, the ln, and you would get the exact same answer. That's the beauty of the change of base rule. It doesn't matter what you change the base to. It'll still give you the same answer. So using either one of those buttons when you're doing change of base is completely fine. Okay, I usually like to stick with the top one. So my answer ends up being approximately 2.52. And there's my answer. All right, same kind of thing in number 4. Number 4, it says 7 to the x equals 70. So I'm going to try method number 1. I usually start with the bigger number. 70 can break down into 7 and 10. But since it's not just 7s, that doesn't really help me. And if I break down the 10 even more, still doesn't help me because those are different numbers, right? I can't just write this as 7 to the something. I would need a 2 and a 5 there also. So that means we can't use method 1. So I'm going to use method 2. That's to rewrite it as a log. All right, so the log base is going to be the same base we have here. That's 7. And then we go in a circle to remind us the order. All right, after the 7 comes 70 equals, and then the next piece is the x. Once again, x is solved for, so all I need to do is type this into my calculator. And in order to do that, I'm going to use change of base. So log of 70 divided by log of 7. All right, so we'll type that into our calculator. Log 70, remember to close those parentheses, divided by log 7. And there's our answer, 2.18. Okay, I'm going to quickly show you another way to type it into the calculator. Now, not all calculators can do this, so you'll follow along with me, and if the button shows up on your calculator, then awesome. It's a nice little shortcut you can use. If it doesn't, though, no worries. Just use the method we've been using. Okay, if I wanted to type log base 7 of 70, so this right here, some of the newer calculators have a little shortcut. And that is in the calculator, if you go into the math button right under alpha, and it's all the way at the bottom of this list, so I'll scroll up so we can see it. All right, right here it's A, it says log base. And what that does is give you the option to type in your own base. All right, and then we don't have to use the change of base property, we can just type it in as is. So I would type in 7, scroll over, type in 70, and then it'll give me the same answer. All right, it's just a nice little shortcut for some of the calculators. Unfortunately, not all the calculators have it, but don't worry, it's really not a big deal if you have to use change of base. It's pretty straightforward. Okay, that's all for today. Thanks for following along. If you have any questions, make sure to write them down. See ya.